Hello everyone, my name is Mouafek Ayadi. I was with the Innovcom 2 weeks ago presenting a similar topic. I've talked about RAG, and I'm happy that there is a colleague that covered this topic today, so we can skip through all introductions about LLMs, about RAG, and deep dive into Agentic AI. So, 3 years ago, there was a new technology on the market called large language models. Everybody uses it today. 2 years ago, there was another new technology called RAG, and it became mature with cloud services. My main focus is Microsoft Azure, and this year, a very new brand technology on the market, which is Agentic AI. And we are moving from traditional softwares where everything needs to be programmed explicitly to agentic softwares. Agentic softwares are softwares that are capable to reason by themselves and make decisions by themselves. It's the first time in human history we are witnessing this, and it's open source. So today, we will not deep dive into theoretical aspects. We will just go through the main concepts and show you something that works in life. So, the summary was about RAG introduction. It was already made, advanced RAG 2. The multi-model, it will take time, so we're going to skip it, and we're going to go straight to Agentic RAG and then the workshop. So, what is Agentic AI? Agentic AI is having the normal concept of agents in reinforcement learning, but they are based on large language models. The novelty of them in 2020, the late 2024 and early 2025, that these LLMs are powered by RAG technologies. For me, I'm using Microsoft Azure to deliver these solutions. And like my colleague, he talked about proprietary data. It cannot be exposed publicly, or at OpenAI, they cannot save it. So we need solutions to protect our privacy. And this is a vanilla example where we have multiple agents interacting with different environments. And why it's vanilla? Because we have an expert agent in web search, expert agent on your chosen platform to send messages to your colleagues and loved ones like Slack, an expert agent to browse all your Gmail. What's going to do, and also we are building on top of the this morning workshop. What you have seen with my colleague this morning, we're going to expand it into having multiple RAGs, and every RAG we have its own dedicated agent. So they interact with multiple vector databases, and they have different objectives. And they follow the architecture, the old architecture we all know, master-slave. So we have a master agent that orchestrates multiple agents, and those multiple agents interact with different environments and provide executions, processing, storing, and understanding the environment. I'm saying this is vanilla because Gmail and Slack are data is very valuable, but it's not complex. So, in 2005, we're going to witness a big shift between traditional softwares and agentic softwares. And agentic softwares are capable to have data in memory, and not just that, build on top of that data. So the data that you have is going to be augmented every time you train your model, or you let your model, basically your LLM, interact with the environment. And you can give it the parameters that you want. So if you are going, for example, to SUBCOM to learn some courses to get your PhD, and there is, for example, a chemistry class, you're going to have an agent who are very professional in chemistry. Another agent very great at physics. Another agent is great at software engineering. And these three agents will be orchestrated by a master agent, and that master agent will have a PhD level. And this is what we are talking about with deep thinking and reasoning. And I'm going to show you in real life how, for example, DeepSeek is working and reasoning and thinking like a human being. There is a benchmark for how smart they are, and these benchmarks are tied to how PhD students can do well on certain subjects. And these agents, they interact with different environments. They have interdisciplinary knowledge, which make them sometimes more efficient than humans. And this is why having a PhD is a difficult thing. To have a PhD, you need to have deep knowledge about several areas, and you leverage them into one topic. Now we have softwares that can do that in a few seconds. Of course, after setting them up, which can take weeks and months. Since I use Microsoft Azure, I can show you the novelty. So just yesterday, they released Azure Agent Service. If you log in and you pay subscription today, you probably will not find it in the Tunis region. I have another laptop. I work in a bank, and the laptop is French. The IP is France, and we pay for it. We are a partner, so we have access to Azure AI Agent Service. We can build niche agents, for example, to do trading in different markets. We mainly operate in Switzerland, Germany, and France, and it takes hundreds of analysts and traders to gather the knowledge of every market and execute the trades. After the execution of trades, we have also a lot of people, like 100 people, we call them post-trade analysts, to analyze what is happening. Now, the trend is to have agents that can help these humans and be more performant on different markets. And this is just, we went from a vanilla example to here talking about a professional example in an investment bank, European investment bank. So, since I'm trying to be quick, if you don't understand anything, I will be here tonight, probably tomorrow morning. Yes. Any of you can ask any question that you want. And if you have basic understanding of reinforcement learning, this will be a big interest to you. So the biggest research field in AI for years has been reinforcement learning, and then deep reinforcement learning. And now we have agents that are built with reinforcement learning to build us more advanced LLMs and RAGs. I will go straight to the workshop and show you something that works in real life. First of all, you can check these platforms. To leverage a RAG, you can build it in-house, which will take months, probably years, because the technology is very complex, and scaling your software will be also complex. In here yesterday on my work laptop, we have the agents. In my personal one, detects a Tunisian IP. I don't have an ISP, so I only have few new options, like vector store, which are the trendy databases. We are no longer talking about SQL databases. We are talking about vector databases, better than graph databases. We are talking also about Azure OpenAI services, and these services are being developed every day. So every week we have a session to just discuss what they've been released and try to implement it in the same week. In here we can see a simple platform, and in here you create your AI projects, and it's specific for LLM RAG projects. Now, if we want to talk about agents, I have this code. It's open source code, and what is simulating a robot. I'm not an IoT guy, but I know how to deal with data, because besides my AI career, I worked as a data engineer. And if you know how to treat data in IoT, for example, you know how to do it in finance. There will be business knowledge differences, but anybody can upscale. The logic almost stays the same, at least for software engineering aspects. So the idea is, I'm going to build a robot that interacts with an environment, and this robot have multiple sensors. So if you have audio sensors, if you have visual sensors, if you have any type kind of sensors, all this will be fed into a vector store where I can embed the data, put it in a vector store, then be consumed by the LLM. And this is what basically ChatGPT is doing, not our own end, but this is how OpenAI have trained it. Now, if you work with a company, for example, an IoT company like the one out there sponsoring Kuvoltis, they can fine-tune their LLM using their IoT sensor data and leverage their own RAG. If you feel this is jargon heavy, believe me, this is the easiest I can do. Now, what's going to happen is the agent, let's assume we have a dog. It's called, the workshop is called the blind dog. Now you have a blind dog in a garden, in a park, and he have two things, water or food. And this blind dog need to go through all the park to stay alive. He either eat or drink. And we need to make this dog stay alive. So he have multiple sensors, and he needs to be autonomous. No human intervention, no explicitly encoding his behavior. So if we see Raytheon dogs, if you see Boston Dynamic dogs, it's mostly explicitly encoded and programmed. Now with the new technologies that we can make this system make the evolution by itself is going to be different. This is not linked to Microsoft Azure, but in order to scale it, we need to do something similar. Like, you know, Google Colab is just for experimentation, and I will go straight to the exploration. So, as you can see, my dog is the red dot, and this is a simulation. Water is blue, food is orange. And this is my park. This is the basic concept of reinforcement learning when you have a grid, a policy, and an agent. My policy is, please find the water and the food to eat them, and do that by yourself. And since this is a simulation, we are not using vector databases, which are super expensive. We are not using cutting-edge technology. It's just a simulation to explain what agentic AI means and agentic RAG means. So, we're going to see the dog looking for water, and we're going to see it looking for food. And we have rules. Do not go outside the grid, and do not die. So if there is no water, there is no food, the dog is going to die. And the problem with this dog, he's blind. He cannot see. So we need an AI agent that can explore the whole park, get the data from the sensors, process all of that. By the way, this is very expensive and computationally heavy. We're going to skip the expensive part and the computational part and show you what it's doing. I'm going to hit Shift-Enter. My dog starts to walk. So right, right, right. He finds the water. He drinks the water. He's stuck. Now he's not stuck. He goes left. Forward, forward, forward. Boom, he have eaten the food, and this is 20 steps. So I have an AI simulation that found the water by itself, found the food by itself, consumed them, and he stayed alive with the resources. So my dog robot can survive in a park by itself. We can apply this to finance. If you are trading in France, you need an agent expert on the French market. If you are trading in Germany, you need an agent expert in trading in the German market. If you want to trade in Tunis, please don't do that. You will lose your money. But also, you can build your agent, but I don't advise it. And that was my first workshop. Without going into the details of the code, it's mostly simulation. Now, who have heard about DeepSeek?
Yeah.
Okay, we have 2, 3, 4, 5, 6, 7. Okay, 8, 9. Okay, 9 people have heard about DeepSeek. So, OpenAI spent $7 billion to build us a large language model, and then the Chinese spent so OpenAI $7 billion, the Chinese $7 million. They cut down the cost. and they do something very genius, and they build DeepSeek, and it's a better reasoning model. So what is a reasoning model? Reasoning model is the more advanced technology than agentic AI. So we have classical machine learning, we have deep learning, and in deep learning we have NLP, and then we have reinforcement learning, and if we combine these technologies together, we can build an LLM, which is a brand new technology. On top of that, the newer one is RAG, then agentic AI, then deep reasoning models. Let's see what deep reasoning model is. It have a reinforcement learning policy to reason by itself, and in this process, it have agents. Every result will be, so the output of an agent will be the input of the other agent. And you have another agents that double check that. So reasoning like a human being is referring to parts of your brain when you know stuff and validated by the other part of your brain when you know other stuff. So the whole thing is influenced by neuroscience, and we call them these expert parts in our brain. In software engineering, we call them agents. So these deep reinforcement learning agents will do something marvelous. So this is the code, it's also open source. They will do something more advanced than NLP, more advanced than LLM, and more advanced than RAG. They will reason. So if you ask the question, and this is a complex question, even a human being, it will take it time to have an answer, and then it answers correctly, 3, 5, 7. And this is a test set, that's why I know it's correct. So it will give you a response, but it will do it like a human being. It will reason. And the word reasoning in here is not a prompt. It's not print. It's actually telling another agent inside the LLM, hey, look and fetch the best information possible for me, and double check it. So it extracts a response, and then it goes into reasoning mode again. Also, the model tell you that he's reasoning. This is not a prompt. It reasons again, and then it gives you an answer, and it keep on fine-tuning its answer until it finds everything correctly. The LLM or RAG have a big problem with numerical data, and is getting better with the reasoning models, which are the AI agents. There is a big, for people who follow the latest research, there is the aha moment. The aha moment is when the LLM was thinking, and for a second he was like, aha, I have a new solution. And it have done it in real life. So these notebooks are called replicating the aha moment, which means replicating having agents that can think like human being. And in here, like you see, the format of reasoning always changes. So it reasons again, and it answers. And that's why we have shifted from traditional, we're going to shift from traditional softwares to agentic softwares. Thank you. If you have any questions, please feel free to ask them now or later.
Okay, thank you, Si Mouafek, for your presentation, your explanations. If there is a question from audience.
Je vous remercie pour cette excellente présentation. Pour moi aussi, c'est nouveau. Donc, juste une question pour le reinforcement learning. Donc, comment se fait le calcul de reward à partir de la réponse d'un agent, sachant qu'il n'y a pas vraiment de métrique pour évaluer si la réponse est vraiment bonne ou pas. Donc, on a besoin d'évaluer pour calculer la reward.
Excellent question. I have seen the math equation. It's frightening. I did not understand it. It's like this big, but the technique is called the GRPO. And the GRPO is a big equation that can evaluate the output of every LLM to give it as an input, and this is how it can reason. I wish I can explain the math. It's too complex for software engineering. Thank you.